Hello everybody, welcome back to another video. So today, by looking at the title, we'll be scratching the surface of calculus. We're going to be doing two simple problems today, and we're going to be introducing, if you haven't watched the last video about functions, you might want to know that for today's video, because if you don't, not going to end well, because with calculus, you need to know functions as well. So for today, most people know how to solve the area of this, right? A rectangle. The area of this equals L times W, right? And the triangle equals the area of this simply equals 1/2 BH, right? Now you know these formulas. Most people know these formulas. You have a formula. Now what if I give you this? So what's the area of this? Now you might say, oh, where's the formula for this? If you just give me the formula, I'll solve it. Well, guess what? There is no formula. This is where calculus comes in. So let's say we have a graph. Just like so. And we'll do this. Now this function right here is x squared. Now let's say these 2 points, 1 and right here, is 4. In this function. We want to find the area. We want to find the area of this whole section right here. Let's say we want to find that area. And we don't have a formula for this. Here's where calculus comes in. So first thing we have to do is we have to make this weird looking thing. Sorry, that looks like a square root. I'm not gonna get too much, but this is basically the sum, really. So I'm not sure, but we just need to use this. And then we'll put our points, so 4 and 1. Okay? Then after that, we have to put our function, which is x squared. Sorry, that's not x. We need to put our function, which is x squared. Right? Then we just need to put this thing right here. Well, I'll explain that more in the video later. Now there's a rule that signifies this. If you look here, we have the square root of 2. So now there's a rule, so you can add x, another x, right? So this will put x here, and then since you're knowing x squared and x, we have x squared. If we add x, just one x, we'll get x to the third power, and then we divide that by the power. So we just divide it by 3, right? So that's right there. So now what we have to do is x. We have this over 3. So then we can simply put 3 over 3. This is our first one, right here. That's the first one. Minus 3 over 3. This gets this area. Using this what we have here and our function, we can get our area, right? We can get the area for this shaded white part right there. Correct. So this is the first problem we're going to be talking about today. This is one of the pretty main things that calculus might be used for, is solving for area and volume, such as shapes that you don't have formulas for, so you have to use this right here. So now, let's get into a different problem. So now we're going to be calculating slope. So if you haven't already knew, we're not going to be calculating slope, but you might want to know this. y1 over x squared minus x1 equals slope, right? So let's see, we have a quick graph right here. And we go up like that, right? Easy enough. So I'm just gonna make up a random function for this. This is not accurate at all. Let's say the f(x) is I don't know. Let's just say 2x to the power 3, maybe plus x, and then plus 1, right? That's your function. This is completely not accurate. So yeah. So let's take a look here. So now, when doing this, we need to calculate this, right? Or in other words, dx over dy. Dy. Dx over dy. So let's just say we're trying to find the point right here. And we're trying to find the slope, right? So we're trying to find the slope. So now slope maybe from here to here is like this, maybe. Then from here to here is like this, maybe. Then from here to here is this. This is slope. This is what we have here. But we're just trying to find this one point, that slope for that exact point. Because if we do maybe, let's just say, from here to here, we have a slope like that. Or if we do from here to here, we have a slope like that. Slope changes. We can't use this equation to find that particular point right in the middle. Now let's change the color from that. You can't use it. So here's what we have to do. So now we have to. So now knowing what our function is, we have to simplify. So no, not simplify, but you know. So f(x) right here, this equals. So let's take a look right here. So the way we will do this is we'll take the coefficient of x and multiply by the power. So 6x. Then, after that, what we'll do is we'll subtract x from that power, which will get us 2. Plus. So this is really just 1x1. We can use the same thing. So 1 times 1 is x. Correct? And then, 1 times 1 is x. And then we do minus 1 instead of 0. Plus 1. So that means this cancels out. So that means our first derivative is 6x squared plus 1. That does not look like a 1. Here, let me do a different color. Find it. Here. Our first derivative is 6x squared plus 1. That's our first derivative. So, that's your first derivative. So then that's one of our derivatives that we have to do. So now using this and using this function that I made up here, this right here, we can get the slope for that one here, and using the derivative dx over dy, right? So knowing that calculus is really advanced for an 11-year-old, please let me know if anything's maybe mistaken here. I think everything's right here. Based off my knowledge, everything should be right here. So now calculus is mainly, so what we use for calculus today in this tutorial was these two things: slope and area and volume. So the area and volume uses these. So I'm trying to make that S. Uses this. And slope uses dx over dy. Knowing calculus, you can find the slope of any point. You can find it here, 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 here. You can also find areas with really weird shapes. You can find the area of this using this right here. That is what calculus is. There's many things for calculus. We are just scratching the surface of calculus today. And I hope you enjoyed this video. I hope you might have learned something from this video. And I'll see you in the next one.